Okay, let's look at the exam questions together. Problem 1. So in this question, you are told that there is an 80% chance of answering any individual problem correctly. Determine the chance that you answer problem incorrectly. So in this question, you are told that the probability of answering individual problem correctly is 0.8. So you need to calculate the probability that you answer a probability a question incorrectly, which will be 1 minus the probability you answer a question correctly. So in this chance, this will be 1 minus 0.8, so you get 0.2. If you're using percentage, which will be 20%. Okay, so let's look at problem 2. Problem 2, it says that a fair coin has come up heads 10 times in a row. What is the probability that the coin will come up heads on the next flip? Be careful that here they say a fair coin. What does this mean? A fair coin means the probability that you will have a head or a tail is the same, which is 0.5. So no matter what happens, the probability that you will get a head coming up is 50%. So in this case, even though you have 10 heads in the row already, you might expect that you should get a tail or something. However, because this is a fair coin, so you still have 50% chance to get a head. Okay, so let's look at the problem 3. Here it says, suppose 90% of kids who visit doctor has a fever, and 20% of kids with a fever has sore throats. What is the probability that a kid who goes to the doctor has a fever and a sore throat? So the way I'm solving for this problem is I'm using the tree diagram. As you see that I couldn't draw a tree in the Excel, so I'll just tell you how it would be if you are drawing a tree. So here is the kids who have a fever. When they see a doctor, the probability is 0.9. So for those who don't have fever, the probability is 0.1. And you are also told that 20% of the kids with a fever has sore throats. So for those kids who has fever, the probability that they will have a sore throats is 0.2, right? So the question is, what is the probability that a kid who goes to the doctor has a fever and a throat? So if you imagine this is a tree, so this says the probability that a kid goes to the doctor has a fever, which is 0.9, and has a sore throat, which is 0.2. So the probability will be 0.9 times 0.2, which is 0.18. That's the answer here. Okay, so let's go to the problem 4. In the stats class, 57% of students eat breakfast in the morning, and 80% of them floss their teeth. 46% of students eat breakfast and also floss their teeth. What is the probability that a student from this class eats breakfast or flosses? So in this question, what you are asked to do is to calculate the probability that a student from this class eat breakfast or floss their teeth. If you remember the general addition rule, this is just like the probability A or B, which is equal to probability A plus probability B. minus the probability A and B. So in this case, our A is break first, our flaws is the B. So to calculate this probability, you just need this formula. So which this one equal to probability you have break first plus the probability that the student will floss the teeth minus the probability a student will have break first and floss their teeth. So you know you already have the probability here, right? Point. So in this one, I'll show you how to calculate that. Okay, we will do this here. So we have the probability break first plus the probability floss minus the probability have break first and floss, which means both. So minus this one. So you will get the probability 0.91. When put it in percentage, it was 91%. Okay. So in this one, it says police report that 78% of the drivers are giving a breath test, 36% a blood test, and 22% had both tests. Find the probability breath test giving blood test. So this is a conditional probability. So the formula for conditional probability, let me show you. So the probability for this one, probability of giving breath test, giving the condition of blood test is equal to the probability giving both having both breath test and blood test over the probability blood test. As I tell you in class that the condition always goes to the denominator. So in this case, we are told that the probability they have both tests is 0.22, right? It's 0.22 over the probability that they have a blood test, which is 0.36. So you don't have to calculate final results. You just need to put a fraction, which is the C in my case. If you need the results, you just hit enter. This is the result. But in this question, we don't need the results, so I will just delete the equal sign. Okay, let's go to the next question, 6. So here it says a manufacturer ships toasters in cartons of 10. In each carton, they estimate a 20% chance that one of the toasters will need to be sent back for minor repairs. In a batch of 5,000 toasters, what are the chances that fewer than 975 need to be returned? So in this one, you are told that the probability a toaster will need to be sent back is 0.2, right? In this case, you are told the P is 0.2. Until in the batch of 5,000 toaster, so this is kind of like a sample. Your sample number N is 5,000, I'm sorry. So you need to find the probability that fewer than 975 toasters need to be returned, which means probability X smaller or equal to 975. So this is kind of because a toaster will be either sent back or not. So this is like a success or failure problem. So you can think of it as a binomial model. However, remember that when you have a binomial model, if n times p and n times q both greater than 10, so you can use the normal model to approximate the binomial model. So in our case, we got the n is 5,000, p is 0.2. So n times p, I got 1,000. And n times q, I got 4,000, which means I can use a normal model. If you use a normal model for binomial model, the mean for the normal. We'll talk about the other questions in next video.